Now, so we'll take one example wherein we'll tell that y is equal to ab plus a of b plus c plus b of b plus c. Now, this is the expression and I need to simplify the expression. Now, why are we going to simplify this particular expression? Because if I construct this particular gate as it is, it require more number of gates there. Okay, now let me see how many gates I require in order to construct this particular circuit. Suppose when I speak about an AND gate, I require a dot b, a of b. There's one AND gate here, there's one AND gate. I require three AND gates, then one, two, three, four. Four OR gates I require. I require four OR gates and three AND gates in order to construct the circuit for this particular expression. So what I'll do is, now we'll try to simplify this one. Okay. Now the first step what I'll do here is, I will open the bracket. I'll open the bracket, and the next step what I have here is AB. I have opened, just open the bracket there. So I'll have AB plus AC plus BB plus BC. Okay, now, so here when you consider AB plus AB, can I write it as AB? So I'll write it as, now this one, B into B is B, because I know the Boolean formula x dot x is equal to x. So I'll make use of that formula, B dot B is equal to B. I'll use that particular formula. So once again here, AB plus AB, I'll write it as single AB. AC, I'll write it here, B, I'll write it here, B here. Now look at that. Now, so think on how are you going to simplify this. Okay, now suppose I said that when we try to simplify, or when I try to take any common term, so after taking the common term, it should further lead me to further simplification. For example, in this particular case, if I try to take A common, I'll get only B plus C. Now B plus C will not leave me for further simplification. So instead of that, now think of these two now. So B plus of BC, I'll take B common so that I'll end up with 1 plus C. So I'll end up with 1 plus C. So 1 plus C, we know that it is equal to 1. So 1 into B, I'll get B. So B plus BC, I can just simply write it as B. Then, so once again, so what I'm doing here is, okay, now again what I do here is, I will take these two terms, AB plus B. I'll take these two terms AB plus B, and from that I'll take B common. So I'll end up with 1 plus A, so that is equal to A. So from AB plus B, I'll write it as B, and AC I will write it as it is. Now this is the simplified expression. Now let me check how many gates I require in order to construct this particular circuit. So I require one AND gate and I require one OR gate. So earlier cases, I wanted 3 AND gates and 4 OR gates to construct the circuit, but now I require only one AND gate and one OR gate. So I have reduced almost 80% of the circuit. I have reduced the 80% of the gates required. So this is the simplified circuit, and the simplified circuit will be y is equal to b plus AC. And believe me, now this expression will have the same output as this the given expression was having. So when I try to check into the truth table, so this expression as well as this expression will have the same output. Okay, now so next, once we simplify the expression, now we'll try to construct the circuit for this. We'll try to construct the circuit for this. In order to construct the circuit, the first thing what I should know is, you should know on how many variables the given expression is depending. In our case, I can tell that the given expression is depending upon 3 variables, A, B and C. So therefore, I'll take the 3 inputs A, B and C. So how are we going to construct that? So what I'll do is, so this is the way we have going to write that. So I'll write A as my first input, I'll write B as my second input, and I'll get C as my third input. Suppose if there was one more input, then I'll draw one more line and I'll call it as D. Now, so I'll try to get AC. So A dot C. So if I write AC, so the gate between AC is an AND gate. So I'll take one input from A, I'll take another input from C, I'll AND it together and I'll get the output as AC. Now next I want B, and B and this output should be OR together. So I'll take one output B and AC. So next is B ORed with AC. Now AC is already there. I'll take the one output from here, one input from here, and then I'll take another input, and these two are connected with an OR gate. So I'll connect this with an OR gate. So when you look into this, so the input coming at this particular point is B, and the input coming at this place is A, and the input coming is here is A. Now since we have got an AND gate, you will get AC. Now since it is an OR gate, you will get B plus AC. Now this is a small example on how to simplify a given expression with the help of an Boolean loss, and how to construct the circuit with the help of an basic gates there. So, okay, now, so in this particular discussion, so we just took one small example of one expression, and we saw that how we can use the Boolean postulates in order to simplify the expression and construct the circuit. So this is the one of the advantage of Boolean algebra. So with the help of Boolean algebra, we will be able to simplify the given expressions. Okay, now so hope you have understood that. So we'll take up some more little complicated problems, and we'll try to do the same thing. So we'll try to simplify that with the help of an Boolean algebra, and we'll try to construct the circuit for the simplified expressions.